right, like you have your meetup, you kind of get into this other level of people, and it's like all the organizers kind of know each other. You're like walking down the street in San Francisco, you're like, oh yeah, that's SF data science guy or whatever, right? Like we're in this like club, but we all know how annoying it is. So yeah, this is, especially over the last 5 years. So here's the meetup. It's the Advanced Spark TensorFlow meetup. We just tacked on TensorFlow. Partially, I think that's probably the best with this. Yeah, have you guys read the TensorFlow white paper? Yeah, anyone like familiar with it? So yeah, it came out of Google, I think back in November, and it's been slowly, right, they've been starting to release more and more, right, like parts of it. And yeah, so you can kind of see behind Google's veil there that the types of things that they're working on and the types of problems that they solve. So it's for their like neural networks. Yes, the reason I started the Advanced Spark meetup was, I think, July 1st of last year. I just sort of noticed, like when I was learning Spark, I didn't really have that. Yeah, so there were, yes, I should start over. There were quite a bit of resources online from Databricks and like AmpLab and all that. But when I would go to meetups, it would just be sort of higher level stuff and like use cases and all these like businessy things and stuff, things that, that actually pay the bills. And so I kind of tacked on the word advanced, and pretty much every meetup we are into code, right? So it like doesn't appeal to like all audiences. So I'm actually going to kind of spin it and do that now. I'm going to pull up some like notebooks and things like that, and just kind of show you guys what types of stuff the Spark Tech Center, the IBM Spark Tech Center is working on, and also what I personally work on as well. So actually there's I think this is the next event, or no, there's a meetup. Yeah, why did I click on this one? Yeah, we actually have a meetup coming up in San Francisco. I've been trying to get down, right, like the peninsula more and more. It's just my whole network is up here, so it's yeah, like this stuff takes a long time to get like venues and things like that. So the people from Galvanize have been really good letting me crash there all the time. So this is the next one coming up. We're going to talk about CUDA, GPUs. We have some like TensorFlow experts, guys actually using this stuff coming in to talk about the neural network. I think we're going to build one actually right there. So yeah, the like audience could follow along. And then there's one after that. I think it's about a week and a half later. We're going to do this workshop. Because it's a Saturday, right? These venues have to turn the air conditioning on. Yeah, this is actually like a big issue, right? Right, like same with IBM. I mean, every single like meetup, I think, because of the age of the IBM building, right, like 425 Market, costs us like $5,000 or something, right? So, yeah, these meetups aren't cheap. So, yeah, in like the whole vein of the 10,000 mark, I really can't even imagine how much money was spent, right? Like doing since 2011, all the sponsors that help out, and all the food and the pizza, and yeah, pizza ain't cheap here. I'm from Chicago, where pizza, is like super cheap, but you get a place that's called Chicago Pizza, and it's like 5 times as much as what I would pay in Chicago, and yeah, obviously it's not going to be as good. So pretty much my entire life is outlined at this URL, advancedspark.com. I created this thing called the pancake stack. There was this movement last year called the SMAC stack, and it was Spark and Mesos and Akka, Cassandra, Kafka. So I actually worked on that, and I had to up it, for 2016. We had to kind of like raise the bar a little bit. So I just went to one of those like word generator things, and I was searching what my phone number spelled out and everything. And it actually spells out Lodi, which is kind of funny somewhere in there, which I don't even know where Lodi is. But yeah, so Pancake Stack, there's this GitHub repo that I have that sort of powers all of these. So Riley, from the beginning, I said, right, this meetup is very code focused. So I created this GitHub repo. Somehow the domain name I've had fluxcapacitor.com for years, but the GitHub repo is actually available to like organization. So just a couple years ago, so I snagged that. And so all the code that goes into these meetups gets posted here. We have about 7 or 8 contributors now. I think people posting when they come and speak, they always put their code here as well. So this is what we use for the workshops. Here's an example, Zeppelin. Yes, I assume right? Since this is a like data science, data engineering type meetup that people use, right? Like notebooks, IPython, that kind of thing, right? Or at least familiar with them. Zeppelin is kind of a Scala-E version, Java-E version. What happened here? This is going to be a even shorter talk if I can't get this going. So what's cool about these notebooks, and this is probably something we could talk, right, like have a whole meetup on, but right, these notebooks give you the reproducibility, so you have code and you can share these things with other people. It's sort of annoying when you share them because they're clobbering on top of like your stuff, but these tools are starting to get better and better. So here's an example. Let's see if this notebook comes up. Where you can actually mix code and then you can put in Markdown so you can basically document what's going on as well. All right, is that connected? There we go. Yeah, that was my flags for later. There were like 500 of them, right? All right, so pull up. Yeah, this is a pretty good start here. So this is where I actually have, when I'm explaining alternating least squares, matrix factorization, collaborative filtering, these concepts, I can actually pull up code right next to these images and sort of talk through them. Not going to get into those details now, but here's another one. This one's kind of fun. I was actually just working on this at the Tacolicious right down the street right before here. Just for full disclosure, this demo that I'm about to show is based on this book, which is probably one of the best books. I mean, I didn't write this. This is my buddy Nick Pentreath. We actually just hired him at the Spark Tech Center. He came up with this book out of nowhere, just boom, dropped and basically changed my life. I mean, it's pretty much all the main concepts that, right, for like machine learning, like collaborative filtering, clustering, right, like different ways to use this data. Really creating data products. Yeah, I put a picture here. He's a damn fine looking guy here. So what we did, what Nick has done, and I was just talking to him last night. Yeah, he's in South Africa, and I never know what time zone he is, so I just like send a text, and he texts back all the time, so I assume we're on the same schedule. Or he's just, he's always checking his phone. He built this as part of his I guess like master's or some sort of like degree, and put it in the book, and it's a really cool example. So I'm going to share it. There's this data set out there. It's called LFW? Yeah, labeled faces in the wild. And it's like the dream data set for like image. Okay, yeah, 3 minutes. So basically all the images or the faces are like all aligned perfectly or as best as possible. And so what we're going to do is calculate eigenfaces. So basically decomposing, if you can take an image and sort of flatten it out into pixels, right? So if you have a 50 by 50 and it's grayscale, it would be 2,500 pixels, or a 2,500 wide vector can represent one image, right? So feed that in, and we're going to feed it into like SVD and then decompose it. This is, so I'll show you guys the, oops, that wasn't good. Can't really read this, but this is the code. This is all on the GitHub repo. It's called eigenfaces. We do a little resizing. So we take the color images that are part of that data set, scale them down, make them grayscale. Yeah, just to simplify the calculations, right? I mean, this is just one node that I'm running here. Convert it into these vectors. We run, we're actually running PCA. We're just picking 10, so K. We're going to decompose into 10 principal components. We get back those principal components. We convert them, that matrix, into a CSV. So this is all Scala backend. I was running that back here. That's why my battery's so low. And then if we run this, so here's, this is George Bush. Apparently he's got the most images for some reason. So he's a good data set. So these are the actual eigenfaces, right? Just kind of a hip term for it. It's more of a colloquial thing than an actual. But these are the eigenvalues. So we have like 10 of these principal components. So like you can kind of see here, it's picking up eyes. Here it's picking up nose and mouth, some of the wrinkles, things like that. Hair, right? So that's just George Bush. Now I ran this before. This is all the people named A that their first name is A. This is their sort of eigen, right? So these are sort of hidden features, right? That are the topmost that explain the data, right? These images. So, and I ran this. Hopefully it's finished. Boom. So this is everyone. So this is an average of every image, and I can't remember how big this data set is. Let me see. But yeah, you start to see things popping out here, right? Yeah, so each of these kind of picked up different features, right? So yeah, kind of cool. Is that it? Okay. Yeah, that's it. So yeah, check out the repo, Flux Capacitor. You can run all these demos. There's a Docker image, pull it down. And yeah, thank you.